Okay, so this video is going to go over lesson 10 from Tuesday, October 27th on comparing linear functions. All right, so we can determine the slope of a line by knowing any 2 points that fall on that line. No matter which 2 points we use to find the slope will always be the same because a linear function has a constant rate of change or slope. Okay, so we learned that already in the previous lessons. So just saying that no matter where you find the slope on a line, as long as it's a line, the slope's going to be the same. So you can find it between 2 points that are really close to each other, 2 points that are far away. It doesn't matter. The slope or the rate of change is constant. Okay, so here is all of our formulas that we have done for finding slope. So we know that slope is m when you're looking at equation y equals mx plus b. We found slope by using rise over run when we were on a graph. Then when we were doing it in a table, finding slope in a table, we did change in y over change in x. And then we have our slope formula for when we have 2 points, finding the slope between 2 points. All 4 different ways to find slope based on if you're given the equation, a graph, a table, or 2 points. They're all ways to find slope. Okay, so this page is just notes reviewing. So here is how you would find slope by using rise over run from a graph. So you'll see that from the point 1, 1 to the point 5, negative 2, they made their slope triangle. They went down 1, 2, 3, and then to the right 1, 2, 3, 4. So the slope here would be negative 3 over 4, the rise over the run. Okay, and then from a table, finding slope in a table, you have to do the change in y over the change in x. So the change in y, you'll see it's going up by 3 every time. The change in x is going up by 1. 3 over 1 is 3, so our slope is 3 for this example. And then we had the slope for 2 points. So if you had 2 points, let's see, so a point, I'll just add the points here, would be negative 2 comma negative 1, and then positive 4 comma 3. Okay, so if those are our 2 points for the formula, you'd subtract the y's, change in y over change in x. So here are our y's. So you'll see they're doing negative 1 minus 3. This is the first coordinate. This is the second one. Negative 1 minus the 3. And then we have a negative 2 minus a 4. Get negative 4 over negative 6. And if you do negative 4 ABC negative 6 or negative 4 divided by negative 6, you'd get 2/3. So this is our slope for 2 points. Okay, so those are just a bunch of examples that we've already done finding slope, just a little bit of review. Now, what about y-intercept? We can determine the y-intercept of a line by looking to see where the line crosses the y-axis. This is where we would have began on our graph. The y-intercept of a line is always the point 0, comma, whatever the y-coordinate is. So we learned that y-intercept on a graph, to find it, you just look and see where does my line cross the y-axis. So here the y-intercept would be positive 1, the point 0, comma 1. From a table to find the y-intercept, you have to look for the point where the x is 0, and then whatever the y-coordinate is, that's the y-intercept. So here the y-intercept is 0, comma 10, so the b would be 10, and the y-intercept is 0, 10. You just have to find the point where the x is 0. The other number is the y-intercept. And then to find the y-intercept from an equation, it's simply the b, so you just have to look and see what number is at the end, just remembering that if there's a minus here, that's included as a negative for the b, the y-intercept. Okay, so that was just some review. Now today's lesson is comparing slope and y-intercept. So first you have to find the slope and y-intercept of each of these lines, and then we're going to compare it. Determine the slope and y-intercept of each linear function given its graph, its table of values, or 2 points that fall on a line. So for here, we're given a graph. Okay, so to find the slope of line A from a graph, we do rise over run. That's the easiest way, at least I think, to find slope. Any 2 points because slope is constant, so it doesn't matter on a line where you begin. I'm just going to begin right here. So to get from this point to this point, we're going to the left. We're going from left to right. I'm going to have to rise 2 and run 3. I made my slope triangle, rise over run. Positive 2 over positive 3. Okay, let me find my slope for line B. rise, run. Rise 3, run 1. 3 over 1, which simplifies to 3. All right, y-intercept. The y-intercept of A, where does it cross the y-axis? This is the y-axis, right? So just picture this graph. Some of you might get confused. You could extend it if you need to. We're just in quadrant 1 up here. This is all the y-axis. The y-intercept, this line is crossing the y-axis at 0, 0, the origin. And if you look at your my line B, the one I'm using the orange marker for, this one also crosses at 0, 0, the y-intercept. Okay, so when we're comparing these, we could state that the y-intercepts are the same, but they have different slopes. They're both positive slopes, though. They're both going upward as you go from left to right. Okay, let's look at B. All right, so we have two parallel lines here. Right, they're never going to intersect. Y equals 3/4 A. That's this line right here. Let's find the slope. Slope from a graph, rise over run. 1, 2, 3. 1, 2, 3, 4. I made my slope triangle to match up these 2 points. Rise over run, 3 over 4. Let's find the slope from line B. I see a point here and a point here. If you want to do this one, that's fine too. All right, make my triangle. Okay, I kind of went a little backwards there. Doesn't matter. Just know that you're counting the rise and then the run. Rise 3, run 1, 2, 3, 4. All right, my y-intercept. So again, you could kind of look at this extended if that helps you guys. We're in quadrant 1. My line y equals 3/4 x is crossing, if I can extend it to help show you guys, it's crossing the y-axis at the origin, 0, 0. What about my line B? Well, this one, just extending it to help show you, it's crossing the y-axis right here at 1, 2, 3, 4, 5. So this would be 3. So my B is 3, but for y-intercept, we're going to write the point. So it'll be 0, 3. So these two have different y-intercepts, but they have the same slope. The reason they have the same slope is because they're parallel. Parallel lines have the same slope. Okay. All right, now let's look at this one. We're given a table, and we have to compare it to a graph. Okay, so now we're getting a little bit more involved here. So first, let's deal with our table. To find slope from a table, we do change in y over change in x. The change in y is that we're going up by 1. The change in x is that we're going up by 1. 1 over 1 is 1, a slope of 1 for the table. Let's find the slope from the graph, rise over run. I see a point here. Looks like it crosses the grid again here, here, and it looks like down here. Okay, so I'm going to do the 2 up here. 1, 2, 3, 1, 2, 3. Rise 3, run 1. I'm doing rise over run for my graph to find slope. Rise 3, run 1, a slope of 3. Okay, my y-intercept. The y-intercept from the table is going to be whenever the x-coordinate is 0, whatever the y-coordinate is, that's the y-intercept. So our y-intercept is right here, 0, 1. Right, the y-intercept always has an x-coordinate of 0, and then whatever the y is, that's the one on the y-axis. Okay, and then let's find the y-intercept from our graph. You have to look and see where it crosses the y-axis. So our line intercepts the y-axis right here at -2. The point would be 0, -2. These have different y-intercepts, and they also have different slopes. Okay, next page. A table and a graph again. Let's compare the two functions. Okay, so let's first find the slope from this table. Change in y over change in x. the change in y to get from 11 to 8, we're going down 3, down 3, down 3. Adding 1, adding 1, adding 1. If you're not sure, go backwards. 0 minus a negative 1, or negative 1 minus a negative 2, and you'll get positive 1. Also, you could check it. Negative 3 plus 1 is negative 2. You can put that in your calculator to check it. Okay, so our slope change in y is negative 3. Change in x is 1. Negative 3 over 1 is negative 3. Great, let me find my slope for my graph now. Rise over run. Remember, that's the same thing as change in y over change in x. The change in y is how much you're rising. Are you going up or down, and by how much? So let's see. I'm going to just do these 2 points. Okay, so I'm going to have to go down 1 and then run 3. Down 1, run 3. So my slope triangle, down 1, right 3. And remember, we know this is a negative slope because the line's going downward as you go from left to right. So our slope is negative 1/3 for that one. All right, our y-intercept from a table, y-intercept is whenever the x is 0, whatever the y-coordinate is, that's your y-intercept. So 0, 2 is our y-intercept for our table. And our y-intercept for our line is where it crosses the y-axis. So if you look carefully, it looks like it's crossing in between. Oh, this is not the y-axis. My bad. Pretend that's not there. That line looked a little dark, so I thought it was the y-axis. My apologies. This is the y-axis. Right, so then we're in quadrant 1 again, so you can kind of picture it like this. It's crossing the y-axis right here at 7. 0, 7. Our y-axis is over here. Our line crosses at 7, so the point is 0, 7. Okay. These have different slopes and different y-intercepts, okay? But both of the slopes are negative. So you know that if you graph this one, it would also be heading downwards. Alrighty, let's look at E. Function 1 passes through the points 0, 3, and 3, 1. And then function 2 is a graph. Okay, so for function 1, to find the slope between 2 points, we're going to use our slope formula, which is y2 minus y1 over x2 minus x1. xy, xy. 1, 1, second one, second one. Okay, so I'm going to take my 1. I like to put them in parentheses just to show you so you don't get confused with the subtraction. So we're doing 1 minus 3. Those are our y's, y2 minus y1. And then our x's, 3 minus 0. Notice I went back to front, back to front. I stayed consistent. 1 minus 3 is negative 2. 3 minus 0 is 3. Our slope is negative 2/3 for our 2 points, function 1. Okay, let's find the slope from function 2. For that one, you're going to do rise over run because it's a graph. Here's a point. Here's another point. I go from left to right, nice and easy. Make my slope triangle. I'm going to have to go down 2 and then to the right 3. Down 2 to the right 3. Interesting observation. Both of those slopes are the same. Okay. All right, the y-intercept. The y-intercept for the first one, well, whenever the x is 0, whatever that y is, that's the y-intercept, whatever the y-coordinate. So we found x being 0, so that's the y-intercept for function 1. And then for function 2, the y-intercept is going to be where our line crosses the y-axis. So here's our y-axis. Our line is crossing right here at 3. So that would be the point 0, 3. All right, what do you notice about these two functions? Well, if they have the same slope and they have the same y-intercept, that means they are exactly the same. So if you were to graph this function, it would be a line right on top of that other line. And if you look carefully, those points are there. So 0, 3 is right here, the point 0, 3. And then the other point is 3, 1, which is right here, 3, 1, 3, 1. So those points are right here. They're the same points that we did our slope triangle for and our y-intercept. So those two are exactly the same. Okay. So again, this was just lesson 10 from Tuesday, October 27th, comparing linear functions. We found the slope and the y-intercept of two different functions, and we were comparing them. All right. Bye.